Good morning everybody and welcome back to another episode of Barham Engines. So first thing this morning we've got the Crossflow engine here that Paul stripped. Now this is the one that we had sitting over on that bench there. So this had all the trick bits in. I think it was all supposedly done. So it had the acrylite pistons, some H-section con rods, all a few trick bits like the vernier pulley and head ported, etc. Now this is the one that I put in a video that for whatever reason we had about 9 thou bore clearance. The only thing we can think happened is on the acrylite pistons, they do run a bigger running clearance than most other stuff. So they run, I think they run about 4 to 4.5 thou running clearance, but the only thing I can think they've done is they've given the same running clearance again. So what you're supposed to do is bore it to the round figure. So this would have been, what, 82.5, I think, for the pistons he had. So you bore it to that round figure, and then that will include the 4 to 4.5 thou running clearance on the piston skirt. I can only think they've gone to 82.5 plus another 4 thou. So anyway, I've spoke to the customer. He had two options at the beginning, we thought. He could either go for some more acrylite pistons, because they go up to about 83.5. We could put liners in it, or he could use a standard piston. But when we sort of got into it and measured everything up, these are the con rods that we're using. And I got in touch with Burton, who supplied the original pistons, and they said, see the part number on the end was LR, which means long rod setup. So this is a bit of a funky setup here. You've got the, like we do on the Cosworth, you put the longer rod, shorter piston, crown to pin height, and what that does is basically gives you less lateral movement on the rod. So the longer the rod, the less lateral movement. If it was short, you'd be getting a lot of lateral movement. So this is the setup we got. So using original pistons is out of the question. So we've gone and bought an 83.5mm acrylite piston, used the existing rods he had. We've ordered all the bearings and gaskets. So I'm just in the process of boring this now. Done the first bore, we'll do the second bore, we've given it a face, and I'll give this Paul to clean up and we can crack on building this one. These are the Rover V8 pistons. So as you can see, if you remember, I machined the bowls to get the right compression. I think we've ended up taking about 1.5 mil out of these bowls, just taking them out of the edge there. So we've got the right compression. As you can see, Paul is weighing and balancing all the pistons. So apparently he's done the pins, circlips and piston rings. Is that right, Paul?
Yes, mate. So well, I've actually weighed the pistons with the gudgeon pins. Yeah. So I've weighed the gudgeon pins separately and put the heaviest gudgeon pin with the lightest piston. Okay. And vice versa. So when it comes to balancing the pistons, I can take less weight out of the piston. Yeah. So I've just done 7, so I've got 1 more to do. Okay. But these are in 0.65, so just over half a gram. Okay. So all this writing on here is with the piston on its own, is that right? No, that's with the gudgeon pin weight as well. Okay. So that's overweight now. That was the bottom number as well, it's just the pistons. Yeah. Weight, what I've rubbed out now. So all these are within the weight, are they? Yeah, so within 0.65 or something, which is for road engines pretty spot on. I mean, I think Roy said before, I've never seen a piston or a production piston less than 2 grams, 2-3 grams out of weight. So these were right. I weighed these actually, obviously before, and they're within 2 grams. Oh right, okay. So quite good really compared to some we had before. I mean, we've had some that have been 6 grams out. Yeah. So it's quite a lot. So you're just removing a bit of weight. Where are you removing the weight from then, Paul? Just basically, there's a little bit around here, a little bit around there. Yeah. What I try and do is basically take an even amount off each side, but obviously in different areas, so you're not taking all the weight out of one bit. Okay. So I'll give these a smooth over with a nicer sort of pad on the Dremel, just to make them nicer finish. Okay. Yeah, just taking the weight out in the right places. Obviously you wouldn't take any weight obviously on this side of the piston. No. When you do it, you want to make sure the gudgeon pin's out of it, so you don't scratch the gudgeon pin. Yeah. Try not to take too much weight off this area, and I try and avoid taking anything out the top. Yeah, anything that's going to
take strength out of it, you wouldn't do, obviously.
But yeah, other than that, it's fairly straightforward, isn't it? It just takes longer because there's 8 of them.
Right, guys, you'll probably remember quite a while ago, we built an M3 engine. This was an E46. It was going in a competition car for a customer, and he wanted it tuned up. So we got reprofiled camshafts that was sort of a copy of the Schrick cams, but with a lot less money. High compression, the pistons in there. We resized the com rod. It was, I think there were arrow rods in there. Obviously competition bearings, bit of head work, all the rest of it. Yeah, so that was quite a while ago. Now this is to do with the thumbnail and title. So we've had a bit of an issue. The gent rings me up saying that he'd had the car dynoed. So the car was obviously built up after we did the engine. So it was some time before the car was completed. He sent it up country, had it rolling roaded. And the next I heard was him sending me messages saying that the car was sort of being rolling roaded, everything was good, and they were just sort of squeezing more power out of it. Towards the end of the day, he got back to me saying the car produced, I think it was getting on 380 horsepower, which was really good power. And he had a track day booked the next day at Snetterton. So, yeah, that was all good. As I say, done all down the dyno. He said at the end of the day, he drove it to the track. He was really, really happy with that. And then he goes and does almost 3/4 of a track day, I think, if I'm right. And he said that the car didn't feel 100% right, and then it started misfiring. So obviously they turned it off. And what he suspected at the time, because we used the existing arrow rods, but one of them had done an end at some point, so we had it resized and obviously balanced all the rods, etc. So he was suspecting it had done a crank, brought the head up, brought the piston and rod up, hit the head, damaged a plug, blah, blah, blah. That's what they were sort of diagnosing at the time. And I said, it's a bit early days. I said, but it's an at this stage, I said, you've got to bear in mind, we hear it all the time. We've had it before with the Cosworth that we've done a video on, Joe's Cosworth, that we built about 4 times, and he had trouble with tuners. I said, not pointing any fingers at all at the moment. We need to inspect it. I said, but we do hear this from time to time. Obviously, first thing is, you've just had the engine built. It's got to be an engine issue or build issue. So months and months have gone past. He's managed to get the engine apart and bought the pistons and rods into us, and this is what we found. So this is probably the worst one, but you see it's damaged the skirt there, and you see the detonation is terrible on here. Now, the other day when we had the engineer in to look at the MGB, while he was here, I said, look, I won't tell you the story, just cast your eyes over these pistons, see what you think. And he said, with the piston crown design, he's seen this quite a lot on the TFSI Volkswagens. He said, this one's number 3. That's obviously the cause of the misfire, and this is the one with the burnt out spark plug. So he said it's been detonating quite bad. He said when it over fuels, you get fuel going to the outer edges of these weak spots, and then it burns out to a point like that. So this one, the skirt's not too bad, but it's, distinctly detonating in our eyes. Because the design of these pistons, you've got no sort of lateral support here, down on the bottom of the piston crown. Obviously, if you don't know by now, pistons are they're not parallel down. The piston will be mating to the bore about this area here, and then the rings take up the top. So the top will be a smaller diameter to the bottom. But obviously with this, where you've got no lateral support, because the detonation, and you can see on the very edge of the piston there, looks like it's been rocking the piston side to side to a point where, if you see these marks down the side of the rods there, that's been touching the oil squirters. So on this engine, with these particular pistons, if you leave the standard oil jets as they were, they're going to touch that bit of cast in there on the piston. So what you have to do is you have to bring them in so they're going in between the rod and the piston crown. Obviously you haven't got much room there, but because these have been sort of doing this, you can see where it's been rubbing rubbing the oil jets, and apparently it's broke 2 of the nozzles off the oil jets, just the end of the nozzles, which isn't going to make a difference to oil pressure. But as I say, the reason this is in bits is not because of oil pressure, it's because we've got a melted piston there. So this is either, in our opinion, feel free to comment, guys, I'm sure you will, and the opinion of our engineer, he seems to think that this thing is running either too much ignition, or it's been running sort of rich, which has burnt that out, or it could be running lean at some point. But it's all the pistons. If you have a look at all the piston crowns, they're all slightly different. I mean, that one there is darker than this one. So I did speak to the customer. He said that the injectors weren't serviced before, so whether it's got injector issue, I don't know, guys. But at this stage, as I say, it definitely looks like a pre-ignition issue. But yeah, let me know what you think about that, guys. So we've had to do a sort of report on our behalf, saying that our opinion is it's got some pre-ignition issue at this point, causing this damage. So yeah, as I say, we're going to get the engineer to do a proper report on it and come back and do a proper one, But it's a bit of an odd one, that, and obviously here it's white good and proper. But yeah, let me know what you think, guys. Update on the pre-Crossflow here. This is the one here that we got the caps mixed up on the rods. So the rod's in the wrong holes to start with, and 2 of the caps are on the wrong rod. So obviously this engine hasn't run. The customer's seen the video, so before I even got a chance to ring him, he rang me up and said he'd seen it. So he's glad that we spotted that. But this engine apparently is a genuine, it's out of a Lotus 7, and it is a genuine Cosworth pre-Crossflow. So I've sort of told him the state of it. We've got the billet machined main caps at the bottom. It's got cast crank, cast rods, and obviously it's got new pistons, but they'll be they're just a cast piston. We've got the billet push rod posts here. The head, he said, will be ported as standard. We're going to measure that, have a look, see what we've got. But at this stage, he's gone away and he said, first of all, I think we were going to build this back up, obviously sort the rods out, and he was going to sell this engine and then do an engine that he's got to put in his vehicle. But because of the matching numbers and what have you on this engine and all the work that's already been done, he said, well, it'd be silly really not to just use this as it is, but install a QED steel crank and rods, which are the sort of copy of the rods are a copy type of the original, so it's period look. So he's going to get those on order. It's a 4.8 length rod standard, I believe. These pistons in this block are about 17 thou below the top while it's on TDC. So they do a 26 thou oversized length rod. So he's going to get them. We're going to get some acrylite flat top pistons, which will, in theory, will be then sticking out about 10 thou above the surface of the block. Then we can do our own compression ratio depending on what we want to run. So he's going to order the pistons, the crank and the rods. So we'll have steel rod, steel crank, trick forged pistons. We're going to order some competition, probably some Cosworth racing bearings, and build him a steel motor really, guys. And then what he's going to do, I think, use the bits out of this to put in another pre-Crossflow block, and we're going to build another engine for him to maybe sell or store, whatever he wants to do. So that's where we are with this one. Just going to wait for those bits to turn up before we can do anything else. Probably get a vernier front pulley if we can get one, just to make sure the timing's perfect. Still got to see what cam is in it. If in any doubt, we shall get a Newman cam in there. But yeah, that's where we are at the moment with this, guys. So quite looking forward to getting this one built, really. So there we are for another video today, guys. Sorry there hasn't been much action today with the machining and assembly, etc. Just thought I'd run you through the workshop. I've been in the office most of the day, to be honest, doing invoicing and paperwork. So yeah, hopefully on Wednesday we're going to have some more action out there for you, but at least you know what's going on out there. Let me know your thoughts on the BMW M3 engine and what you think there. It's a tough one, but unfortunately, not very often is it you know, an engine build issue, especially if it's done a whole day on a rolling road plus half a track day. It's unlikely, but yeah, still got to conclude that one. But thanks very much for watching, guys. Until another video, we'll see you again. Take care.